Hi, in this video, we're going to try to find the value of a constant in a quadratic equation. So in this case, k is the constant in this quadratic equation, whereas x is the variable. And we're told it has no real solutions. Now, we use something called the discriminant to reason about the number of solutions for a quadratic. So if we had a quadratic equation, ax squared plus bx plus c equals 0, then the discriminant was b squared minus 4ac. We've seen this in previous videos. And if that discriminant was less than 0, we have no solutions for quadratic. If the discriminant was equal to 0, we have one distinct solution, also known as equal roots, because if the two solutions are equal, then we only have one distinct solution. And if the discriminant was greater than 0, then we have two distinct solutions to the quadratic. But in this case, we're told there's no real solutions. So that means that if there's no real roots, the discriminant is less than 0. So let's write out our a, b, and c. The a is the coefficient of the x squared term. So it's been a bit sneaky here because it's put the x squared term second. So the coefficient of x squared is minus brackets 2k plus 3. So let's just write minus 2k minus 3. The b is the coefficient of the x term, which is k minus 1. And the c is the constant term, which we can see at the end is minus 1 here. So now let's work out the discriminant. We've got b squared minus 4ac is less than 0. So b squared minus 4 times a times by c, we're saying is less than 0 if there's no real roots. And now we just need to simplify and solve this quadratic inequality. So the k minus 1 squared is k squared minus 2k plus 1, and then just simplify the rest of it. We've got negatives all over the place here. Let's just simplify it bit by bit. We've got the minus 4 times minus 1, it's going to be just plus 4 times minus 2k minus 3. And then we've got k squared minus 2k plus 1, and it's going to be minus 8k minus 12 is less than 0. And then we've got k squared minus 10k minus 11 is less than 0. Now remember, with quadratic inequalities, we want to get we want to get 0 on one side, and then we want to factorize it. So that's going to be k minus 11, k plus 1 is less than 0. And then what's the solution going to be? Well, you can use your quadratic inequality solve in your calculator. But what we could do quickly is that if I just do a little quick sketch on the right, and the x-axis is actually the k-axis, and we're going to sketch y is equal to k minus 11, k plus 1. Then it will have roots of minus 1 and 11, like that, and it's going to be a quadratic like this. Now, we're saying that the y value of this, the y value is this thing here, the y value is less than 0. Where does that occur? Well, we can see the y value is less than 0 in this section of the graph here. So we can see the value of k is between minus 1 and 11. So k is between minus 1 and 11, and that is the solution to this. So whenever k is between minus 1 and 11, this original equation is going to have no solutions for x. Right, what about the next one? So this time again, we're going to write out our a, b, and c. We're told this time it has two distinct real roots, so that's where the discriminant is greater than 0. You can see in that last case here. So let's write out a, b, and c first. Always do that first. So we've got a is equal to 3, b is equal to minus brackets 3k minus 1, so we could write minus 3k plus 1 if we negate that. And then the c is this constant term at the end here, which is minus k plus 3. So that's what c is. C is minus k plus 3. So again, we're going to work out b squared minus 4ac. So b squared minus 4ac. And we're going to say that is greater than 0 because we have distinct roots, it says. So b squared is minus 3k plus 1, all squared, minus 4 times a times c. And we're saying that is greater than 0. So let's just simplify. If I expand this out, you're going to get 9k squared minus 6k plus 1. And then what else have we got? We've got plus 12k And then we've got minus 36. And then simplify further, 9k squared, it's going to be plus 6k minus 35 is greater than 0. So let's hope that I can factorize this. I think it's probably going to be 3k and 3k. And I think it's probably going to be 7 and 5. So I think it's plus 7 minus 5, which let's just check. That gives you 21k minus 15k, which is indeed 6k. And then if we were to sketch it quickly, with k as the x-axis, so we're going to sketch y is equal to 3k minus 5, and then 3k plus 7. Sorry, it's a bit squished. So we're going to have roots of 5 over 7, and a root of minus 7 over 3. And the quadratic is going to look like this. Now, this time, we want this y value here to be greater than 0. So where's the y value greater than 0 on this graph? Well, we can see it's the two tails. So that will be when k is less than minus 7 over 3, or, use the word or, k is greater than 5 over 7. So that will be the final answer. So if k is in that range, that means this original quadratic will have two distinct solutions for x.